What you need to know about metallic character. Metallic character is going to decrease from left to right across a period, and it is going to increase as you go down a group. So we can look at this image of the periodic table, and we see that this arrow talks about an increase in non-metallic character as we go from our most metallic elements, which are down here, to our least metallic elements, which are over here. And metallic character is going to increase if we go in this direction. The best groups to look at in terms of differing in metallic character is groups 14, 15, and 16, which are located right here, where the elements at the top are all nonmetals, but as you go down a group, the elements display more and more metallic-like properties. Fluorine, which we see right here, is our most active nonmetal on the periodic table, and it is located in the upper right-hand corner. We contrast that with francium, which is found at the lower left-hand corner of the periodic table. And in this image of francium, there's only trace amounts that exist in this sample for very small amounts of time. Paramagnetic. Unpaired electrons generate a magnetic field due to its spin. An atom or an ion that contains unpaired electrons is attracted to an external magnetic field. Such atoms or ions are known as paramagnetic. Consider the electron configuration of silver. Now silver has 47 electrons. So if we were to write out this electron configuration, we'd say it is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d9. But we know by looking at this is a situation where it is in our best interest to take an electron from this 5s2 and promote it up to this d sublevel. So really what we should see here is 5s1 and 4d10. What makes this paramagnetic is the fact that this 5s1 subshell is not filled. We only have one electron here. Therefore, this is just partially filled. So what I like to say to students is that the P in partially matches up with paramagnetic. So you can identify an atom or ion as paramagnetic if you can see a partially filled subshell in its electron configuration. We contrast that with diamagnetic. Diamagnetic means when an atom or ion in which all electrons are paired is not going to be not attracted to an external magnetic field. This is known as a diamagnetic atom or ion. So consider the electron configuration of an ion of sulfur. In an ion of sulfur, we're going to have 18 electrons. So in this situation, the electron configuration would be 1s2, 2s2, 2p6, 3s2, 3p6, because when we add this up, we see the 2, and the 6 right here. That gives me 10 electrons, and the 2 and the 6 that we see here gives me 8 electrons, which adds up to 18 electrons. All the orbitals in the subshells that are represented here are completely filled and paired with another electron. Therefore, they are diamagnetic. So I like to say done is basically the D in done matches the D in diamagnetic. And that's how you recognize a diamagnetic atom or ion.